welcome to this video on two very special types of numbers called rational and irrational numbers. Let's do a quick review of the type of numbers that we've experienced. All right, our first type of number, all whole numbers greater than 0, we also call those our counting numbers. Those are called natural numbers. So that's what you learned about in kindergarten. And then we told you 0 was also a number. So all whole numbers, including 0, are called whole numbers. Integers are the set of whole numbers and their opposites. Okay. Then we have a kind of number called a rational number. It's a number that can be expressed in the form of a divided by b, where a and b are integers and b does not equal 0 because you are not allowed to divide by 0. It's a rational number. And finally, we have the set of real numbers. The set of numbers that include all rational and irrational numbers. And so this is what we're going to talk about today, rational and irrational numbers. So what are rational numbers? If you think about the word rational, it means kind of normal, somebody who makes sense. Okay, so if you think about it in that terms, that will help you with determining rational and irrational. A rational number can be a proper fraction, such as 1/2, that's your a divided by b that our definition over here was talking about. Right here it said a divided by b where b does not equal 0. You could also have 3/4 as a proper fraction. 2/3 is a proper fraction. I could go on and on. Those are just some examples of proper fractions. Improper fractions. I could have 12/5. Remember, an improper fraction is where the top is larger than the bottom. 9/4 is an improper fraction. Maybe 19/2 is an improper fraction. Mixed numbers, we don't really use those as much in high school, but that's where you have a whole number and a fraction written together. So 3.5, 2 1/3. These are just some examples of mixed numbers. Integers, remember an integer is a set of whole numbers and their opposites, so we could have 3 and -3. That's an integer and its opposite. We could have 5 and -5. We could have 4, we could have any number really, 1,000. All of those are integers. A repeating decimal. So a repeating decimal is it follows the exact same pattern over and over and over and over again. So we could have 0.333, and then sometimes they'll put a line over the top, meaning it's going to go on forever with the 3's. Maybe we'll have 0.2121, 21, and maybe they'll put a line over the 21 saying the 212121 continues forever and ever and ever. It has to have the exact same repeating pattern. And then a terminating decimal. Terminating means stops. So that means it does not go on. So 0.3, 0.75, 0.97. All of those are terminating decimals. 0.879. They stop. They go a certain number of spaces and end. So a terminating decimal is a decimal with a finite number. Finite means ending. Okay? So a terminating decimal is a decimal with a finite number of decimal places. A repeating decimal is a decimal with one or more digits that repeat without limit. Okay, so one thing that sometimes you'll see is 0.01001, 0001. This is not a repeating decimal because the pattern is changing every time. It's not exactly the same. For it to be repeating, it'd have to be 0.01, 01, 01. Okay, so this is not repeating. That one is. Okay. And then kind of the opposite of a rational number is the idea of an irrational number. In our language, the word irrational means somebody or something that doesn't make sense. It's kind of crazy. And so irrational numbers look a little bit crazy sometimes. So a couple things you need to know about irrational numbers is that they are numbers that cannot be written as a ratio of two integers. And by ratio, I mean a fraction. Okay? They cannot be written as a fraction. An irrational number, if a number is irrational if the square root of a non-perfect square. We're going to be talking about these shortly. I wanted to introduce the words before we started the actual math. If a non-perfect square is a non-repeating, non-terminating decimal. And what you want to look for is that a radical stays in your answer. If you simplify your radical and it's still there, then it's going to be irrational. A number is irrational if a decimal is non-repeating and non-terminating. It's going to be irrational. So let me give you a couple of examples. So the square root of 14. Pretty soon we're going to be practicing with these. That's not a perfect square, so when you simplify it down, the radical will remain in it. Pi is an irrational number. It has no pattern and goes on forever and ever and ever, so it's non-repeating, non-terminating. 0.91233197, blah. It just goes on and on. That's a non-terminating, non-repeating decimal, so that's going to be irrational. Let's try just a couple of these. Maybe pause the video, take a look at these, give them a try, and then come back and check to see how you did. All right, so I have 0.875. 0.875 ends. That means it's a terminating decimal. And if something is a terminating decimal, then it is rational. 0.4 with a bar over. That means 0.44444. That's a repeating decimal. Repeating decimals are rational. All right, I have 0.20, 200, 2000. So this is not repeating the exact same pattern. It's changing a pattern as it goes. So it's non-repeating. And see the ... at the end. That means it's non-terminating. And if something is non-repeating and non-terminating, that makes it kind of crazy. It's irrational. The square root of 15. Is 15 a perfect square? It is not. And if it's not a perfect square, it's irrational. Okay. The square root of 40. Is 40 a perfect square? It is not. That makes this irrational. The square root of 81. Is 81 a perfect square? It is. That means when you simplify it, the answer is going to be rational. So hopefully you did really well with that, and we will be using this vocabulary as we simplify our radicals later.